back to the discussion on experiment 2. In this video, we are going to discuss how to write the Python code to find the angle of intersection of two curves. Suppose if you have the curves r1 equal to f of theta 1 and r2 equal to f of theta 2, then we are going to find the angle of intersection of these two curves. As we all know, the angle of intersection of two curves is defined to be the angle of intersection of their tangents. Okay, so initially we find the angle between the radius vector and the tangent to these two curves. Then we will take the difference of those two angles. That will be taken as the angle of intersection of these two curves. To find the angle between the radius vector and the tangent, we shall recall this formula. If we have the curve r equal to f of theta, then the angle of intersection of the radius vector and the tangent is given by phi equal to tan inverse of r into d theta by dr. Okay. Or we can simply write tan phi equal to r into d theta by dr, or the equivalent expression of this is cot phi equal to 1 by r into dr by d theta. Okay, these are the formula. I mean, this or this or this. You can use any relation to find the angle between the radius vector and the tangent. Then we will take the difference between these two angles. Say, for the first curve we get say phi 1, for the second curve we get say phi 2. Then just take the difference of these two. That will be the angle of intersection of these two curves. Okay. Looking into the procedure, okay, let me recall the working procedure for computing the angle of intersection manually. So first you have to consider these two curves. You have to consider R1 and R2. That's the first step. Then you have to find tan phi 1, tan phi 2. These two will have some particular value. Then after finding that, you have to solve this expression to get some particular value. Solve and get a value. For example, say you get tan phi 1 equal to some 0. So tan phi 2 equal to say 1. Then you have to find phi 1 and phi 2. How do you find phi 1 and phi 2? By taking tan inverse. So in the next step, take inverse on both sides. So I will get phi 1 equal to tan inverse of, just I'm taking these values as examples. So tan inverse of 0, then phi 2 equal to tan inverse of 1. Then just take the difference of these two, phi 1 minus phi 2. So this will be the angle of intersection of the curves R1 and R2. Okay, recalling the procedure. First, you have to consider the given functions. Then you have to find tan phi 1, tan phi 2. Then you have to solve those expressions and get the value. Then take tan inverse on both sides. Then the required value is the absolute value of whatever this value you get, tan inverse of 0 and tan inverse of 1. Okay, this is the procedure. Looking into the procedure to write the code, so the first step is recalling or just calling the library function. First you have to call for the library function. Next, define what are R1 and R2. So before that, if you call the library function simply, then you have to define which variables you are going to use. If you are calling any other library function, then nothing to worry about. So then you have to find tan phi 1 and tan phi 2. Almost the same working procedure I have to follow. Then I have to solve this expression. Sorry, solve. After that, take inverse. For inverse, we write the code A tan for tan inverse. Then take the absolute value. Okay, this is the procedure I have to follow. Let me write a code to find the angle of intersection of the curves. equal to 4 into 1 plus cos theta and r equal to 4 into, okay, it is actually 5. You can write any constant, it doesn't matter. 1 minus cos theta, right? Okay. So here for writing the program, we don't have the convenience for writing theta, so we use t. So r and t are the variables. Okay, r and t are the variables. Let me write the code. Okay, before coming to this, yes. Okay, let me take a new cell. This is the new cell. So first, since I am using symbols, I'll write from simpy import star. I think only this library function is enough for our discussion. If we find the need of any other library function, later we can add it, no issue. Since I am using the variables r and t, I should write r comma t equal to symbols of single quote r. You can write r comma t or you can just write rt. Both are accepted. Then R1, the first curve, R1 equal to, as I said already, this 4 times of 1 plus cos t. So 4 r 1 plus cos t. R2, R2 is 5 times 1 minus cos t. So I just have defined what is R1 and what is R2. Okay, then I have to find the derivatives. dr1 equal to derivative of r1. So dr1 equal to, I have to differentiate r1 with respect to t. So that will give you dr1, or you can say dr by dt. Then dr2, that is differentiation of, or I have to differentiate r2 with respect to t. Okay. So we got dr1, and that is dr by dt, dr1 by dt, and dr2 by dt. Next, let me use one more symbol, t1 equal to r1 divided by dr1. So t1, that is nothing but tan phi 1. So tan phi 1, shortly I'm writing t1. This is the formula I'm going to use there. This formula I'm going to use. So tan phi, I'm writing r divided by dr by dt. Okay. So similarly, T2 equal to R2 divided by dr2. Then Q equal to, I had to solve this, right? So I had to solve, which expression I had to solve? R1 minus R2 with respect to which variable? T. When you solve this expression and call the value as Q, the value that I said already, 0 or 1, as I take the example there. So whatever the value you get, that value will be stored in this variable Q. So that value I should get back. So for that, get back, I should substitute in the expression. So let me call W1 equal to T1. So in the expression T1, you have to substitute SUBS. Which value you have to substitute? That should be written first. T. Since I'm calling the value from the memory location, the syntax will be slightly different here. Earlier we have different notation. Say a substitute y dot substitute within bracket x comma t, just like we had expression there. But here I am calling the value from the memory location, so the syntax will be slightly different. T colon, I have to call for the float value from where it is called from the memory location q of 0. Then w2 equal to t2 dot subs colon float of q of 0. Okay. The values are called off, then substituted in the expression. Now I had to take the tan inverse of that. So let me say y1. You can use any variable, no issue. Y1 equal to a tan of w1. Y2 equal to a tan of w2. Right. Then w equal to absolute value of y1 minus y2. Print the angle of intersection is the angle of intersection is we want to print the value in float. So 0. For 4 decimal, I want the answer percentage W. Let me run. So it's 1.5708 is the angle of intersection of those two curves. 4 into 1 plus cos t and 5 into 1 minus cos t. There are some curves which will intersect orthogonally. So what do you mean by orthogonal? So the angle of intersection is 90. The angle of intersection is 90 degree. When it comes to the radius, the angle of intersection will be pi by 2. Okay. Such curves are said to be orthogonal curves. Okay. So how to conclude that whether the given curves are intersecting orthogonally or not? So for that, you can say the given curves are orthogonal if their angle of intersection phi1 minus phi2 equal to pi by 2. Pi is approximately some 3.14 something, right? So by 2 it is approximately 1.57. So the angle of intersection is approximately 1.57. That leads to the conclusion that given curves are orthogonal. Curves are orthogonal. So in addition to that, you can write few more lines to check whether the given curves are orthogonal. Okay. So if you had to round off the value, round of which value? Float value of W. You have to round it off to 2 digits. If it is equal to float value of 1.57, then print given curves are orthogonal. Okay, that's just a need. Okay, it's the given curves are orthogonal. If you take, let me take instead of cos here, let me take sine and execute it. Then the angle of intersection is 0.7854. Now it is not saying anything about orthogonality. So I can add one more line if you wish. Else, that means if the float value of 2 when it is rounded off to 2 is not equal to 1.57, then print the given curves are not orthogonal. Here, since the value is not 1.57, it says that the given curves are not orthogonal. So this is how you can verify whether the given curves are orthogonal or not. So this is the Python code to check the angle of intersection of two curves and whether the curves are orthogonal or not.